Thanks so much, Anne-Marie. Thank you so much for being here. I'm absolutely thrilled to talk to you about the science that we're doing to try and help save this population. Now, you just heard about their dark past, their precarious situation, and the challenges that we face. So I thought I would start my talk on a high note. I'm so excited to share we found 4 different right whales this summer in the Gulf of Alaska as part of the International Whaling Commission's Power Survey. We were able to get photos of 2 of them, and the bottom animal that you see was confirmed as new. So we were able to add 2 animals to our catalog and 1 confirmed new animal. And not only that, but this is still a healthy population. It's small, but the animals that we see are really robust. They have clean skin with few parasites. They have very few scars. So the odds are stacked against them, but there is hope. These guys are resilient. They're survivors. All right, so let's get into it now. So what is their current status? Well, as you heard from John's talk, they were once distributed widely throughout the North Pacific. Then they became the target of historical whaling. And then if you look at all of these sightings and acoustic detections over the past several decades, you can see that their actual range is considerably smaller than that. Because of their critically endangered status, NOAA designated 2 areas of critical habitat that are outlined in red, a large one in the southeastern Bering and a smaller one in the Gulf of Alaska. To get an abundance estimate, NOAA began conducting surveys in the Bering Sea in the late 20th century. From those data, they came up with a population abundance estimate of only about 30 animals. Within that, only 8 are females. And a recent study by Pastene et al. Found that the sex ratio for this population is 3-to-1 male biased, which is the opposite ratio you want when you're trying to rebuild a population. And although these data are specific to the Bering Sea, the scarce sightings data outside of that area suggests that the total population size is fewer than 50 animals. So this population is facing extinction, potentially within our lifetime. And unfortunately, there is still so much about this population that we don't know. One of our biggest questions is their migration routes. We know that these animals can be found in Alaskan waters in the summer and fall, but what we don't know is where they go when, or even if they leave those feeding grounds. We do suspect that they migrate south, like many large whale species do, and this is supported by the limited sightings data. We've had 1 instance of a right whale that was sighted in Hawaii in 1996 in April that was later sighted in July of that same year. And then more recently, in 2021, an animal was sighted off British Columbia in June that was then re-sighted a couple months later in August in the Gulf of Alaska. But these 2 instances are still the only 2 high to low latitude matches that we have for this population. And interestingly, in almost 40 years of photo ID data collection, we have never had a match between the Bering Sea and the Gulf of Alaska. And so this suggests that this population might be further divided into 2 subgroups, although it's still hypothesis at this point. And then interestingly, in February of 2022, cod fishermen spotted 2 North Pacific right whales skim feeding about 40 miles northeast of Unimak Pass in the Aleutian Islands chain. And to my knowledge, this was the first overwinter sighting of feeding of right whales in the Bering Sea. So this suggests that some portion of the population may remain in those feeding grounds over winter, and that correlates with our acoustic data. Another big question we have is population trends. Most of the studies on this population began after their numbers were already reduced to the low tens. And because of their rarity and the extreme size of their area they can be found, we have a very low re-sight rate. Only 15 animals in our catalog have ever been re-sighted. And so because of this, we haven't been able to get an updated population estimate since that number of 30 that's from 2010. And so we don't have a population curve for our animals. It looks something like this. Once in the tens of thousands, drop down to what we think are the high hundreds, and then nothing until our abundance estimate from 2010. We don't have a population curve, we have a single point. Another question we have are calving grounds. We haven't seen a calf since 2004 in the Bering Sea. And even if you look at the old whaling logbooks, even those logbooks say that there was no evidence of calving grounds located in the North Pacific. And yet, despite that, we have had a few sightings of non-adults. We had a subadult that was seen in the Gulf of Alaska in 2005, another one off British Columbia in 2013, and more recently, we had a juvenile in the Bering Sea in 2017. Now, these animals were all calves at one point with mothers. So this begs the question, where are the cow-calf pairs? Are they someplace that we aren't able to look or don't know about? Is it just that they're so rare that we can't find them? It's one of our big questions. So how do you study a population of fewer than 50 animals in an area that's extremely large and remote and difficult, where you don't even know some of these basic life history questions? Well, one of the best ways we can do that is using passive acoustics. Luckily, right whales are highly vocal. They make primarily 3 call types. The first one is called a gunshot. It sounds exactly like you would expect based on the name. I took out the sound clips to save time, so now you get to hear me imitate them. So they also make an up call, which is thought to be a contact call between individuals, which sounds like a whoo. And then they also make a variety of moans and tonal calls, which is, very exciting, I know. So we use passive acoustics primarily 2 ways. The first is with our short-term monitoring, and this is what we do when we're out at sea. Melissa's talk set up the use of sonobuoys nicely, so this is an instrument that allows us to monitor for calling animals in real time. And they also have directional capabilities. So if we start hearing one of those right whale calls, we can deploy multiple sonobuoys and then triangulate on the whale's position and then give that information to the vessel where we can then hopefully spot the animal. And with these instruments, we've been able to not only monitor for right whales over a very wide area most years, but we also can provide insights into their shifting distributions. And we've found that in years with warmer sea temperatures, the whales are much more widely distributed than they are in colder years. And that correlates well with some data previously published by our colleague, Dr. Alex Zerbini. But the real bread and butter of our work is our long-term passive acoustic monitoring. So we deploy recorders that sit out on the ocean floor for a full year, recording sounds to an internal hard drive. We can then retrieve those instruments, put out a new one, and analyze those data for the presence of right whale calls. And everywhere you see a dot on this map is where we've got some of our acoustic recorders deployed, either past or present. And from these data, the circular graph you're looking at, those bars indicate the presence of right whale detections at the corresponding month. And so you can see that we have right whale detections in their feeding grounds essentially year-round. But then, more importantly, in recent years, we're actually getting detections farther north in the Bering Sea as the sea temperatures continue to rise. One other little interesting acoustics fact about our population, they've actually been documented to sing, much like what you see with humpback whales, although the songs of right whales are comprised almost entirely of gunshots. And so far, this hasn't yet been documented in the other populations. So I think it's fascinating that one of the smallest and most endangered populations has been found to sing. We're also conducting prey studies. My colleague, Dr. Dana Wright, has been modeling their zooplanktonic prey in relation to changing oceanographic conditions. In years where we have a really strong, cold bottom layer, their copepods, or their primary prey, are abundant in the southeastern Bering Sea within their habitat. But in years where that cold pool, that bottom water temperature is absent, those copepods are shifting farther north to stay within that cold pool. And we're seeing likewise a similar shift in right whale distribution as they continue to target those prey. And that's correlated also with our acoustic data. And that list is certainly not comprehensive of the work that we're doing, but I think it's made more impressive when you realize that all of the work in recent years we've been doing is a result of piggybacking on other surveys from our collaborators or taking advantage of opportunistic surveys. By piggybacking on these surveys of our colleagues, we've been able to continue to deploy those long-term moorings, continue to deploy sonobuoys and monitor for right whales in a wide area. And we've actually been able to get photo ID photographs, add new animals to our catalog, like the animals from our power cruise this summer. And we're actually using those mark recapture photo ID data to try and get an updated abundance estimate for this population. So stay tuned for that. And this is all really amazing, but it's not enough. We've been able to do a lot, but we need to have dedicated ship time in order to be able to really work these animals and to further our knowledge. If we're able to get photo ID photographs, we can match those animals to our catalog. That gives us information about population status and migratory routes. We can infer about the health of the animal or the age and maturity. If we can collect biopsy samples, which is a small sample of skin and blubber, we're able to tell the sex of the animal, reproductive status, diet, exposure to toxins and health. If we're able to deploy satellite tags, we can determine their fine-scale movement and habitat use patterns. Hopefully, the tags would stay on long enough to answer some of those migratory route questions. And if we're able to collect prey or fecal samples, then we're able to tell not only what these animals are eating, but whether their diet is changing as a result of these climatic conditions. And all of these research methods are vital to our understanding of this population, but they're not possible without the dedicated ship time, which unfortunately we have not had since 2010. Everything that we've been doing recently has all been opportunistic or piggybacking on the surveys of our collaborators. And while this has been extremely helpful and we've been able to add to our knowledge, it doesn't allow time for us to divert to the animals to then obtain those photographs and those samples that we so desperately need. And most of the time, those data are not suitable for getting abundance estimates. We also need to expand our acoustic monitoring efforts. We do have really good coverage of their Alaskan feeding grounds, but as John mentioned, this is a 5-state and 3-country species. This is not just found in Alaskan waters. So we need to further our collaborations, not only with our American colleagues, but also with our international collaborators as well. And we've been working with DFO Canada to analyze some of their moorings along the coast of British Columbia, and we've been able to detect right whale vocalizations at some of those, which might be another key to our understanding of their migratory routes. And we're also excited about the possibility of using satellite telemetry. This has been proven a successful tool so far with Atlantic and southern right whales. And it's still very much in development for our population and our region, but we think this might be helpful to either confirm species if we get a report of a right whale that doesn't have a photo to confirm. And in the future, it might actually help us survey in areas that we cannot access. Currently, satellite coverage in Alaska is very spotty. The region is usually covered in clouds, but we might be able in the future to use satellite telemetry to help us survey areas in the North Pacific that have better coverage and where right whales were once historically distributed. And so I want to wrap up by saying that we do have a long way to go, and there's a lot that we don't know about this population. But despite the challenges, despite the limited resources, we have been able to learn so much about them already. We're continuing to add new animals to our catalog. We've been able to track their shifting distributions as a result of climate change. And all the animals that we see, again, they're healthy, they're robust. But we need to have the dedicated vessel time to continue to further our knowledge. You know, this population is resilient. They're survivors. Recovery efforts are worthwhile, and we need to be able to do what we can to give them their best chance at recovery. So to talk about those recovery efforts, I'm going to turn it over to the North Pacific Right Whale Recovery Coordinator, Dr. Jenna Malik. Thank you very much.